Welcome to this puzzle session. Here is the problem. Integers are placed in each cell of a 10 cross 10 table. So we have a 10 cross 10 table, I hope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes. We have a 10 cross 10 table. Integers are placed in every cell of it. And it is found that no two neighboring integers differ by at most more than 5. So any two neighboring integers differ by at most 5. And what are neighbors? Neighbors are those which share either a vertical edge or a horizontal edge. So these two are neighbors while these two are not. So for instance, this has 4 neighbors, these 4 things, while this has 3 neighbors, these 3 things, and this has only 2 neighbors, these 2 things, and so on. So the constraint that we have been given is that any two neighboring integers differ by at most 5. We want to show that 2 of these must be equal. Okay? So it's a local constraint that locally something has been given, that some neighboring property has been given, but one has to prove some global thing that somewhere there sit 2 integers which are equal. So very interesting. And as usual, you are encouraged to pause the video before we look at what I'm going to discuss and find your own solution, of course. And with that, let us continue. Right. So we have this 10 cross 10 grid, and the main idea is to record the maximum and the minimum integers that it has. So let's say the greatest of all these 100 sits somewhere here, and it may appear multiple times, and that's okay. If it already appears multiple times, then we are done. And the minimum sits somewhere, let's say here. So just to be very, very clear, let me write capital M is max of the integers, and small m is the min of the integers. Okay, and the main observation is you can go from this cell to that cell in at most 18 steps. The number 18 comes from somewhere, we will talk about it. But first of all, what is a step? A step is either a walk in the horizontal direction or in the vertical direction by 1 unit. So this is a step, this is a step, this is a step, this is a step, but this is not a step. Okay, so from here to there you can go via this route, and you have taken at most 18 steps simply because in the worst case you would be walking from here to there, and here you come in 9 steps, and then you further come there in 9 steps. So total 18 steps, and that is the main observation. So one can go from little m to capital M in at most 18 steps, but we are given that in every step you are not hovering away from more than 5, right? So if this is m and this were the minimum, so this is either again m or m plus 1 or m plus 2 or m plus 3 or m plus 4 or m plus 5, but that's it. It cannot be m plus 6 here. All right? So every time you're incurring a difference of increment or decrement of at most 5. So if you take this path, we see that capital M is less than equal to little m plus number of steps that you have taken, at most the number of steps that you've taken, into 5. That's the thing, and therefore this is the case. This is 90, and now we have 100 integers, but all of them are lying in an interval of length 90, right? So 90, or perhaps I should say 91, because you have taken a difference. So these 100 integers are all coming from a set of size 90. This is little m, this is capital M, all right? But either you use common sense or call it the pigeonhole principle. This just means that 2 of these integers must be equal. 100 integers, but coming from a set of size 90, 91, you have to pick one integer multiple times. That's it. So it's a very, very short solution of a nice problem, and I hope you enjoyed it. And with that, I want to end this lecture. As usual, like, comment, share, subscribe, and I will see you next time.